Physical quantities and units. A physical quantity consists of a magnitude or size and a unit. For example, it would be no good asking for a piece of carpet 3 by 2 without specifying whether you meant 3 meters by 2 meters, 3 yards by 2 yards, or some other unit of length. Another example, if you were offered payment of 5 for a job, whether you did the job would probably depend on whether the units were pounds or pence. To avoid confusion, the SI or Système International has been adopted by scientists around the world. This consists of 6 base units. I'll list the units in this table. First we have mass, the unit is the kilogram, abbreviation kg, length, unit the metre, abbreviation m, time the second, with an s, temperature in the Kelvin, which is a capital K. Note that the abbreviations are a capital letter if the unit is named after a person, and a lowercase letter if they're not named after a person. Electric current is the ampere, capital A, and the amount of substance is the mole, abbreviation MOL. There are also derived units, which come from combinations of the base units. I'll run through a few examples by listing them in this table. First, velocity, which is in units of meters per second, abbreviated as ms to the minus 1, and that is already in base units of meters and seconds. Force is in units of the Newton. Note, even though this is named after Isaac Newton, in the word it gets a lowercase letter, in the abbreviation it gets an uppercase N. Now a Newton is a force that would give an acceleration of 1 meter per second squared to a mass of 1 kilogram. So the equivalent of a Newton in base units is a kilogram meter per second squared. Charge is measured in coulombs, abbreviation capital C, and that is equivalent to a current of 1 ampere flowing for 1 second. So a coulomb in base units would be an ampere second. Pressure is units of pascals, abbreviated to capital P lowercase a. Now Pascal is a Newton per square meter, and a Newton previously we quoted as a kilogram meter per second squared, so the Pascal comes out as a kilogram meter to the minus 1 seconds to the minus 2. And the last example of energy with the unit of the joule, abbreviation capital J. Now a joule of work is done if 1 Newton moves through a distance of 1 meter, and therefore combining the newtons from up here we get that the joule in base units would be a kilogram meter squared seconds to the minus 2. When doing calculations, your data will often be given in non-SI units, such as centimetres, kilonewtons or megajoules. You must know what the prefixes mean and how to convert. So I'll run through a list of the prefixes you need to know. 10 to the minus 12 is known as pico, and the abbreviation is a lowercase p. We tend to go up in thousands, so 10 to the minus 9 is known as nano, abbreviation lowercase n. 10 to the minus 6 is micro, and that is the abbreviation of the Greek letter mu. 10 to the minus 3 you'll be familiar with as milli, abbreviation lowercase m. 10 to the minus 2, not following the trend of going up in thousands, is centi, as in centimetres, abbreviation lowercase c. Then we get on to multiplications. 10 to the 3 is kilo, abbreviation lowercase k. 10 to the 6 is mega, which has an uppercase m to distinguish it from milli with a lowercase m. Do be careful with these. 10 to the 9 is giga, which is uppercase G. And finally 10 to the 12 is tera, which is an uppercase T. When doing a calculation, convert to SI units before starting the calculation. Then your answer will be in SI units. You can always add a prefix to your answer if it's appropriate. Let's run through a very simple example. A snail travels 54 millimetres in 2 minutes. What is their average speed? Well, 54 millimetres is 54. The milli prefix means times 10 to the minus 3 metres. I'd be tempted to write my answer like this, rather than converting to standard form of 5.4 times 10 to the minus 2 metres. Your calculator will never get this wrong, whereas you probably will get it wrong occasionally, especially under the pressure of an exam. 2 minutes is 120 seconds. Now we can write down our formula. Speed is equal to change in distance over change in time, which is our distance of 54 times 10 to the minus 3 metres over 120 seconds, which comes out at 4.5 times 10 to the minus 4 metres per second. If appropriate, we could then say that that is 0.45 millimetres per second. Take great care when calculating areas and volumes. Here we have 1 square metre. Now a metre is 100 centimetres, and very often students will think that a square metre is 100 square centimetres. But a square metre is 100 centimetres by 100 centimetres. So the area will be 100 times 100, which is 10,000 square centimetres. In millimetres, it would be 1,000 millimetres by 1,000 millimetres, so the area in square millimetres is 1 million square millimetres. For volume, here we have 1 cubic metre, which is 100 centimetres by 100 centimetres by 100 centimetres, giving a volume of 1 million cubic centimetres, or 1 times 10 to the 9 cubic millimetres.